In this video, we'll talk more about how do you actually go from converting a string, a SQL statement, into things that Python can handle and can store and can represent. So in the last video, we talked about the fact that one kind of messy part of SQL statements is that you're allowed to have a lot of white space in a lot of different places. You're allowed to have them before statements, after statements, in the middle of statements, all over the place, and it's really not meaningful. So one important principle to learn about, well, how do you deal with a lot of meaningless white space, is you actually break apart your Python strings into tokens. So the exact process for how do you go about breaking apart a given input into tokens, we can have a whole class on that. In fact, there is a class, my Translation of Programming Languages or Compilers course talks a lot about how to tokenize input. But for this class, we can get by with a pretty simple way to do that. So let's examine an example SQL statement. So what we have here is a perfectly legal SQL statement that has white space just kind of all around the place, but it's still quite clear what this is supposed to do. It's supposed to create a table named myTable that has a name column and an age column. Okay. Now what are the tokens here? Well, I'm going to colorize the different tokens by alternating their color. So the first token is this create, and then table, and then myTable, and then a parentheses. The token here is just a single character, and then name, and then text, and then comma, and then age, and then integer, and then parentheses, and then semicolon. Okay. So these are all of the different components of our larger string. So that we'd love to be able to do is convert a string like this into a big list of tokens, where each token is a single element, a single string in this list. So let's talk about how do you go about making this happen. Well, it would be really easy just to split on whitespace, but that doesn't quite work all the time. For instance, that wouldn't capture the fact that myTable is a separate token from the parentheses, or that text is a separate token from the comma, which is separate from age. You have to be a little bit smarter about how you break that up. So you probably write a function that takes in one character at a time, and then if it hits whitespace, it says, oh, this is the end of a token. All right, so that's a good starting point. However, it's a little bit messier even than that. So, for instance, text, with those single quotes, you're allowed to have white space inside them, and you definitely don't want to be breaking up your text into multiple tokens and removing meaningful white space that's inside your strings. So, for example, here is a string, a Python string, a SQL statement as well, that has a SQL style string in there, my space name. The wrong way to tokenize this would be to break it up into a list like this, where I have insert into myTable value, parentheses, single quote, my name, single quote. Because now we've removed all of the information regarding whitespace within the string. Do I know if there's whitespace between my and name? No, and I've just lost that information. In fact, I wouldn't know if there's whitespace between the quotation mark and my, or between name and the closing quotation mark. So this is the wrong way to tokenize. The right way to tokenize is to say insert into myTable values, parentheses, and the whole string is one token. It's single quote, my space, name, single quote, double quote, close. So the whole string is just one token. You're not allowed to ever break apart that string into smaller bits, or else you'd lose information. All right. So in a later video, we'll work through the process of writing code that would break apart a SQL statement into tokens. But let's say that we got this process working. We were able to tokenize SQL style statements. So once you have a list of tokens, you need to start actually processing them. You need to actually do what that SQL statement commands. So easy thing we can start with is the fact that all statements need to end with a semicolon. So you should check that the last token is a semicolon. If it isn't, raise an error. And then you can remove it from the list of tokens. Okay? We check if it's there, we get rid of it. It's not meaningful after that point. The other thing we need to talk about is the fact that some of these tokens that we're reading in should actually be merged together. That even though we broke them into separate tokens, they're really one entity. For example, integers. Okay? Integers can have a negative sign in front of them. So if we had, say, our token list looks like this, where we have stuff, we have comma, we have a minus sign, and then we have a number followed by other stuff, we can go, oh, that minus sign actually belongs as part of that integer. And we can actually merge those two together to say, actually, these aren't two tokens, minus and then an integer. This is actually one token, a negative integer. So you can go through your stream and look for places where you can merge tokens together. Another place you can merge things together are for real values. So real values can have a negative sign, they can have an optional 0 or other integer, and they can have a decimal point and then another integer. So one thing to make your guys' lives easier is we promise that all the real values that you'll encounter will have a decimal point and no exponentiation, none of that capital E stuff. So for example, if in our token list we have a minus 53 dot and then the fractional component, we can merge all these together to just become negative 53.89, so forth. So at this point, we still just have a list of strings. But in reality, when we need to store a lot of these values, some of these values should stay strings, like the text. However, some of those values should be converted. So we need to make sure and check for, oh, this isn't just any sort of string. This is an integer. I should convert it. So, for instance, let's say this string, single quote, howdy, single quote. The single quotes aren't actually part of the string. What they're there is actually to denote the beginning and end of the string. Once we've figured out, oh, this is a string, there's the beginning of the string, there's the end of the string, those single quotes no longer serve any purpose, and you can remove them. Another thing to note is, for instance, our integers, the string -4, we can convert using the Python's int function to just be a -4. Or the real value, we can also convert that to be an actual floating point value using the float function, and then obviously the null value can just become none. All right, so after you've converted, now you have a list of tokens. Some of them are integers, some of them are none, some of them are floating point values. And we'll stop there with regard to converting the text string, and let's start thinking about, well, how do we actually store our database in Python? So there's a couple different places where you can think, well, where do you store all of the rows and schema and all that information? Where should that be stored? Well, one place you could store it is in the connection object, right? This connection object is the thing that you keep saying .execute, .execute, .execute. So that connection object needs to be able to access all of the information. Why don't you just store it in there? Well, the problem becomes, and it won't be really a problem for project 2, but it will be a problem for future projects, is that you are able to connect to the same database multiple times. So it'd be really terrible if only one connection had the ability to save objects from the database, and then if you have another connection, it's just going, there's nothing here. So the problem with storing in the connection object is you may have multiple connections to the same database. So the connection object is not a good place to stick it. Well, where's the other obvious place to store it? Is in a file. I mean, that is what SQLite does. However, in a file is a little bit tricky, especially for project 2, because you don't know how to read and write multiple relations to a file. I mean, if it was just one relation, oh, you could just store it as like a CSV file or an XML or JSON. But for right now, we're not going to be bothering with actually storing the content from the database in a file. Instead, what we strongly recommend for project 2 and onwards is storing it in a global variable. Now, I know global variables are evil, but they actually are quite useful here. So what this means is that you have a global module level variable in your python.py file, and every connection you make to the database will be able to see that global variable and do things like read from it for select statements or write to it for create table or insert into statements. And so once again, we strongly recommend using a global variable to store your data, at least for project 2. All right, so what would the project 2 look like from the beginning? Well, all I'm going to do is just show you just a scaffold for how project 2, at least my project 2 solution looks. So the first thing is that we have this dictionary that stores all of the data for all of our different connections. All right. And then we need to have that connect function that takes in a file name, and it needs to return a connection object. Okay, and here we're just creating a connection object and passing the file name along. Now, what does this connection object look like? Well, it has to have a class. So it inherits from object, and it has a init method that takes in that file name, and right now that doesn't do much of anything. And it also needs to have an execute method which can take in a query, and that query is a string that we tokenize and do all the stuff with. And then at the bottom of the file, we need to actually have room for all of the things that does everything we want. Like we have a class that represents a database, or we have a class that represents tables, or a class that represents rows, however you want to store that information. And so really all of the work for this class is really defining those last 3 lines, but this is kind of how I have my project 2 laid out. So one question you can ask is, okay, so I said we need to store everything in this global or module level variable. Here I'm calling it _all databases. Well, multiple choice question, why is all databases a dictionary? All right, so what is actually in all databases? Well, the thing to be aware of is that for this project and future projects, you can have multiple databases, and each database can have multiple connections and multiple tables, and things get kind of nested and complicated. So the correct answer here is actually all databases is a dictionary because it holds a mapping of file name, like test.db, to a particular database, which are all of the tables stored within that particular database. So that we could have a test.db database, but we can also have a students.db database and a grades.db database, each of which have multiple tables within them. So the correct answer here is all databases for needs to be a dictionary because it's a mapping of a given name, specifically a file name, to a database.